I'm going to create a graph of a rational function according to these instructions over here. And then once we have the graph set up, we're going to find the equation for it. So be careful how complicated and fancy you make your graph. You might end up regretting it once you come to the equation portion. So the first thing it tells us to do is make two x-intercepts. And you can make more than two, but we're going to pick at least two. And I'll just pick them at -4. And I don't know, let's mix things up a little bit and put one right here at the origin. Okay. Next, I want vertical asymptotes. Okay, so oops, that's my pen. I want two vertical asymptotes. So let's see. Oh, non-zero vertical asymptotes. So those can't go at x equals 0. Fine. We'll just put one right here in the middle of those two dots at -2, and we'll put one over here at +3. Seems nice. Okay, and now it wants a horizontal asymptote at y equals 0. Okay, horizontal asymptote at y equals 0. And now a non-zero y-intercept. Okay, so we'll just stick a non-zero y-intercept on here somewhere. Let's make that red. How about located at -3? Okay, this is great. We've got some mess ups in here already. Can you see the problem? The problem is you can't have a y-intercept and an x-intercept located at different places. So it's showing us that one of these choices from earlier was a bad choice. So let's not get too fancy with where we put that x-intercept. We'll put it over here at x equals +1. Okay, and I still want that horizontal asymptote at 0. All right, now we should be ready to make our functions. So we just start writing our equation. And I know if you actually put in something that looks exactly like mine, the program would have told you it's wrong. But let me explain why it's wrong. F of x equals, and I need a fraction, and I'm going to put my x-intercepts on top. Let's color code those so we all see what's going on here. That's going to be x plus 4 and x minus 1 are my x-intercepts. And then I want those two vertical asymptotes on bottom. That's going to be x plus 2 and x minus 3. Well, hang on a second. This thing is equal weight, right? When you have an equal weight rational function, what it causes is a non-zero horizontal asymptote. And that's completely violating the instructions that it said over here, where we said we want a horizontal asymptote. Remember that part right there? We want a horizontal asymptote at y equals 0. So it means I need this thing to be bottom heavy, which means there needs to be another factor on the bottom, which means another vertical asymptote. So I don't know, let's just stick one over here. I just need 3. It said at least 2. I tried 2. That wasn't great. So let's try 3. And that's going to be x minus 5. And you'll see that will get okayed by the program. That right there is fine. And now the next job is to figure out what the equation. Okay, so let's see. What did we do here? I've got my nice y-intercept plotted on there. And I need to finish off the equation. Well, I don't know what the equation is yet because there's still some letter in front that I need to figure that out. So the way we're going to do that is we're going to say plug in a non-zero y value. Could be any y value anywhere in the graph that's not 0. And you see, it's not like we have a whole lot of choices here. We're going to plug in 0, -3. So what that means is -3 equals a times 0 plus 4 times 0 minus 1 divided by 0 plus 2, 0 minus 3, 0 minus 5. Okay, now who knows if this is going to work out nicely? Sometimes it doesn't. But on top, we're going to have -4a. All right, on bottom, we're going to have 1530. I think that works out to 30. Okay, that's fine. That's a big number. So we get -90 equals -4a. And we divide each side by -4, and we get, no, that's not too nice, is it? We get 45 over 2 equals a. Okay, fine. So it's ugly. The important part is we found the a value that goes in front. So we're just going to say 45 over 2. And then we have all the rest of those factors. X plus 2, x minus 3, x minus 5. On top we have x plus 4 and then x minus 1.